So do you need help trying to calculate the original price of an item that's on sale? And you know what the percent of the sale is, you just don't know what the original price was. Don't fear. In this video, we're going to break that down step by step. We're going to show you how you can go from a sale price to the original price with no problem. We'll have a few examples, step-by-step instructions, and also a few problems where you can actually practice yourself if you like. So all that's coming up next on The Land of Math. All right, in this video, we're going to look at how you can find the original price of a sale item. So first of all, let's look at how you can find an actual sale price of an item. So let's say we're at the store and we have a price of an item that is $30. So our original price is $30. And it happens to be on sale for 30% off. So a 30% discount. What we would do is try to find out how much we're going to save. So we take the $30 times 0.30 or 30%, and that gives us 9. That $9 represents how much we're going to save. So to find our actual cost, we would take the $30 item, we're going to subtract the $9 that we're going to save, and we end up with $21. That $21 is our sale price. Now, let's look at the number one mistake that most people make when they're trying to find the original amount. So we know it's $21 on sale. We know it was 30% off. So this is the biggest mistake that I'll see students make. So again, we know it's $21. We know it's 30% off. So what students will do, or people in general, they'll take the $21, the sale price, and they'll try to find 30% of it. So they'll multiply it by 0.30, and they'll get $6.30. And what they'll do is they'll take the $21, our sale price, and add the $6.30 to it. And they get $27.30. So they would think that would be the original price, but it's wrong. It's not right. Because we know at the start here, it was $30. But we ended up with $27.30. We're off by like $2.70. So what happened? All right, and how do we even find the original amount? Okay, so the biggest mistake is, if you look here, we're taking the original amount and we're subtracting 9 to get to 21. So what we have to think of is this. What we're actually doing is taking the whole amount, whatever it is, and we're subtracting a percent of the whole amount. So in this particular problem, the sale was 30%. So we're subtracting 30% of our whole amount. So the first whole amount, we could just think of it as 1W. And the sale we would think is 0.3W. And if we subtracted 1 minus 0.3, we would get 0.7. So 0.7W equals P would be like our equation, like a one-step equation. And so if we plugged in the $21, it would be 0.7W equals 21. And we want to isolate the W, get it by itself, so we're just going to divide by 0.7. When we divide both sides by 0.7, on the left side is just the W, and on the right side, we get our 30. And then we know that's what the original whole amount was. It was $30. So this is correct. Now, you might be asking, where did we get 0.7 from? Well, the whole amount would represent 100% of the cost. And then we're subtracting 30%. So a sale is like how much you're saving. If you subtract the whole amount, 100%, minus what you're going to save, that leaves you with 70%. So 70% represents what you have to pay for. Okay. Now, a lot of these you can just do in your head. So for example, if something is 10% off, it means you have to pay for 90%. If it's 25% off, it means you have to pay for 75%. 65% off, which is a good sale, you still have to pay for 35% of it. If you found a deal that was 99% off, it means you only have to pay for 1%. All right, in this next section of the video, we have 4 different problems that you can practice if you'd like to. So you can pause the video and go and try them and then check your answer. Now these first 2, I'm going to set them up as equations, and the last 2 kind of do a shortcut. So in this first problem, you can see I'm taking the 1W minus the 0.15 because it's a 15% sale. And it's going to equal $63.75, our sale price. When I combine the 2 W's, I get 0.85. So it's 0.85W equals $63.75. So basically I have to pay for 85%. We're going to divide both sides by 0.85. And when we do that, on the left side, we're going to end up with just W. But on the right side, we're going to take $63.75. We're going to divide it by the 0.85. And when we do that, we end up with $75. So the original price before the sale was $75. On the second problem, same thing. I'm taking the 1W for the whole amount minus the 0.4W because it's 40% sale. And the sale price is going to end up $72. So I combined my two W's, and so 1 minus 0.4 would be 0.6. W equals the 72. Again, I'm trying to get the W by itself, so I'll divide by 0.6. I'll do that to both sides. On the left side, I'm left with just W, and on the right side, I'll take 72 divided by 0.6, and when I do that, the whole amount was 120. Now, in these two steps, we're going to kind of shortcut it. So I know the whole amount is 100%, so if I subtract the sale price, 20, I get 80. So I just do the total sale price, 64, divided by the 80%, 0.8, and I get my answer of $80. So the original price was $80. And the same on this right side, on question number 4. It's a 22% sale, so I take 100 minus 22 and get 78. So I take the sale price, the $195, I divide it by the 78%, which is the percent I have to pay for, and when I do that, we end up getting $250. So that was the original price. Well, hopefully this video was helpful. If it was, please give it a thumbs up. We'd love it if you would subscribe to the channel. Until next time, we'll see you on the Land of Math.